This is question number 4 from 1.6 practice A. So we are solving the systems of equations with 3 variables. So the first thing I want to do is number my equations 1, 2, and 3. All right, so I notice right away that my system does not have any equations with 2 variables. So that means I need to evaluate each equation to see which 2 would be easiest to eliminate one variable to create a situation that has an equation with just 2 variables. So I'm going to look at equation number 1 and 2 because equation 1 and 2 have a 2x and a negative 2x. So I see that those can be eliminated pretty easily. So that means that I am going to choose equation 1 and 2 in order to eliminate my x terms. All right, so we have a 2x plus y minus 3z is equal to 9 for equation 1, and negative 2x plus 4y minus 2z equals 16 for equation 2. So right away, my 2x's cancel out, and I add straight down, so I have 5y minus 5z is equal to 25. So that's one equation in terms of y and z. I need 2 equations in terms of y and z, so I'm going to take equation 2 and equation 3, and I'm going to eliminate my x terms in order to get another equation in terms of y and z. So I'm writing equation 2, and then equation 3, all right, so I know I want to get rid of x terms. We have a negative 2x, and then we just have x. So I know I want them to be the same number and opposite sign. So I want this number in front of x to be a positive 2. So I'm going to multiply this whole equation at the bottom by positive 2. So I have my equation 2, which is negative 2x plus 4y minus 2z. And then after I multiply everything in the second equation by 2, I have a positive 2x plus 6y minus 4z is equal to 22. So now I can eliminate my x terms, and I'm left with 10y minus 6z is equal to 38. Okay, so now I have 2 equations that are in terms of y and z, and I'm going to use these 2 equations to solve for one of my variables. So 5y minus 5z is equal to 25, and 10y minus 6z is equal to 38. So the easiest thing I see right away is that I have a 5y and a 10y. I can make 5 look like 10 by multiplying it by 2. I also need it to be opposite, so I'm going to multiply my top equation by negative 2. So I'm going to multiply negative 2 by everything in this first parenthesis, and I have negative 10y plus 10z equals negative 50. And then I have a positive 10y minus 6z is equal to 38. That bottom equation does not change. So I eliminate my y's. I add straight down for my z's. So I have 4z is equal to negative 12 divided by 4. And z is equal to negative 3. All right, so I have one solution. Now I can use the solution and plug it in to one of my equations in the green box to find y. So I'm going to pick one of my green box equations, and I'm going to plug in z is equal to negative 15. So 5y minus 5 times negative 3 is equal to 25. So 5y plus 15 is equal to 25. Subtract 15 from both sides of the equal sign, and you get 5y is equal to 10. So therefore y is equal to 2. All right, so now I have two solutions. Now I can pick one of my equations, my original equations, to find x. So I'm going to pick equation 1. And then I'm going to substitute y is 2, so 2x plus 2 minus 3 times negative 3 is equal to 9. So 2x plus 2 plus 9 is equal to 9. So 2x plus 11 is equal to 9. You subtract 11 from both sides of the equal sign. So 2x is equal to negative 2. So therefore x is equal to a negative 1. And those are my three solutions.